This video will be dedicated to a single example, namely a projectile launched horizontally from a height above the ground. So we'll analyze that. And there's the projectile moving at 20 meters per second. Shot from the gun. It's horizontal, so this is a vector representing the velocity. 40 meters above the ground, so that's important. This is the range, how far it goes. And the projectile hits the ground. So we're going to solve for the time of flight, and that will be done with equation 5. So the fully expressed equation 5 is here. We have a final position and an initial position. Now let me just say that the way I usually like to solve problems is to say that my initial vertical position is 0. Now, you don't have to do that. You may look at this problem and say logically to me it's 0 down here and 40 meters here, and that's okay. You can do that. But I generally will say this is 0. Wherever I'm at is 0. And so when I get down to the bottom here, it's negative 40 meters. Mathematically, it works out exactly the same. So you can take your pick. I'm just letting you know how I'm generally going to be solving these problems. So why 0 is equal to 0? In other words, we can just quickly make that assumption. That's my 0. And so I can go from there. Well, Vy0 is equal to 0. There's no initial vertical velocity. We'll do that next after this example. All right, so then we have t down is the square root of 2y. Take the 2, bring it over here, divide by g, bring that over here, square root. That's our time down. And that is square root of 80 over 10, which is 2.83 seconds. Recognizing that the horizontal did not have anything to do with the vertical motion or the time. I shouldn't say or the time, because time is part of the vertical motion, right? Time it takes to get to the ground. Solve for the range. What's the range? How far did this projectile make it? Not what's the length of this path that I'm tracing out here, but what's the range, the horizontal distance along the ground to the destination. Well, range, distance, velocity times time, but it's the x. The vertical has nothing to do with getting it along the ground, other than the fact that it's helping it stay in the air. But the vertical or the horizontal velocity times time is what the answer is. 20 times 2.83, 56.6 meters. So that's the range. Now let's get the velocity at the moment of impact. So it impacts the ground here. But the velocity at the moment of impact is just what it says. It's a vector quantity, and vectors have size and they have direction. And it's a combination of the vertical motion plus the horizontal motion. So you better include all that. So here we go. We got the Vx. We also have the Vy. These are two vectors perpendicular to each other. It gives us a resultant vector of some magnitude and some angle theta. So this is what we're going to solve for. Magnitude and direction of the resultant. So this will be on a test on this unit. And you will have to solve for a similar thing. If you just give me the vertical speed, you'll have 1 of 4 points. It'll be worth 4 points, and you have to have everything. You have to have the horizontal speed or velocity, and that's 20. There's a point. Then we have the vertical velocity. Vertical velocity is found from equation 3, most easily in this case, I think. Vy0 minus gt. There is no Vy0. So it's just minus 10 times t, which gives you minus 28.3 meters per second. Or you could say 28.3 meters per second down. Some of you listening to this video, when I ask this question, will be inclined to give me this answer alone. It happens every year. I've been doing this too long. I know it's true. You'll give me this and say that's the answer. And you'll have 1 of 4 points in the problem, because you didn't do this, and you didn't combine them together to give me the speed of the projectile. It's square root of the sum of the squares. So let's do it. We do it, and we get 34.7. That's how fast it's moving. That's the size of this vector. Then for your final point, you better give me the direction. Theta is the inverse tangent. Opposite, over, which is Vy, over adjacent, which is Vx. So plug in the numbers, out pops the answer. Minus 54 degrees, and so our full answer is 34.7 meters per second at minus 54 degrees. And if you just say minus 54 degrees, I'll know that what we're talking about is with respect to the positive x direction, which is the reference frame that I tend to use in projectile motion, because we're talking about practical surface of the earth type phenomena. And so along the ground is the most sensible thing. Is it below the horizon, below the ground, above the ground as far as angle? How far did it move along the ground? So if you don't specify with respect to, I'll assume it's with the positive x. You won't be doing it with respect to negative x. Sometimes, perhaps, with respect to positive y. So there's the analysis of that type of problem. And in the next video, we will just spice it up a little bit by launching it at an angle. We'll take it at an angle and do a full, what's considered a regular, quote unquote, projectile motion problem. See you then.